Postmen, as part of the transport and logistic branch of industry, are facing a lot of challenges. Cities are growing bigger and bigger. Along with it, the volume of traffic increases. Additionally, more and more packages have to be delivered while having a lack of persons who are able to do the job. These are all factors that make the daily job of a postman hard and stressful. In general, there is no value creation while the postman is driving the vehicle to reach the spots at which the delivery actually takes place. Thus, there is a potential for optimization in the last mile of the whole process. To make the daily job of the postman better, Genesis focus on this last mile. To exploit this potential, Genesis aims to develop an integrated vehicle and system technology that enables largely emission-free and automated delivery of goods in urban centers. Consider a city pilot who is able to head to positions without any driver on board where the presence of the postman is not necessary. But to be able to achieve this vision, a lot of work in the field of safety assurance has to be done. Automotive vehicles are classified in a taxonomy by the Society of Automotive Engineers in the levels 0 to 5, where 0 means that there is no automation and 5 means fully automated. In between, at least some parts are automated, which more and more reallocates the responsibility from the human to the automated vehicle. Following the taxonomy, the city pilot is located at SAE level 4. This means that the presence of a human is not necessary. On board, he acts more like a passenger. To fulfill this, several driving conditions need to be met. For instance, that the automated vehicle is only allowed to drive in a city and not on a highway. But what if the vehicle is going to leave the city? Then the operational condition would not met. For example, if the depot is located outside of the city, in this case, the vehicle can request so that the human should continue the operation by transferring the responsibility to the human. But the human does not need to respond, which transfers the responsibility back to the automated vehicle. In this case, the vehicle will move into a safe state by its own, for instance by driving to the side strips and then stopping. It can be seen that monitoring the operational design domain is absolutely necessary, which leads to our first research question: how can the operational design domain monitored at runtime? On the other hand, the handover of responsibilities, as explained before, should be done in a safe manner. This leads us to the second research question: how to handle a safe change of responsibilities. Until now, we considered a human as a passenger, but a human on board who always needs to help if the vehicle is having a problem will not help to optimize transport and logistic processes. But to able to optimize this process, the goal of Genesis is to remove the human on board by a so-called off-board safety driver. The imagination is that there is a remote command control center in which multiple off-board safety drivers are helping automated vehicle to come out of problems remotely. This would allow also the supervision of a whole fleet so that relation of one human supervises one vehicle is not necessary anymore. This leads to our next research question: how to handle a safe remote change of responsibilities. On the other hand, the relationship between human supervisors and automated vehicles can now be considered as asymmetric, so that the supervisions need to be coordinated. This leads us to the fourth research question: how to handle the coordination of responsibility with an asymmetric number of vehicle and off-board safety drivers. To demonstrate the results of the Genesis project, we set up a lab consisting of a remote command control center, model vehicle, and Genesis similar environment. The first mission for the autonomous vehicle is to drive from the parking lot to the depot to get loaded with the delivery packages. At the start of the day, the logistics center sends the list of mission to command and control center. The command control center operator assigns the list of mission to an available autonomous vehicle. Then the operator activates the first mission and sets the driving mode to fully autonomous driving. This causes the autonomous vehicle to drive from the parking lot to the depot. Finally, the autonomous vehicle arrives at the depot to get loaded with packages, which completes the first mission. The second mission for the autonomous vehicle is to drive from the depot to the postman's home to pick him up. First, the command control center operator activates the second mission for the autonomous vehicle. Then, the autonomous vehicle drives from the depot to the postman's home. Finally, the autonomous vehicle arrives at the postman's home to pick him up, which completes the second mission. The next mission for the autonomous vehicle is to drive with the postman as a passenger from his home to the first drop-off point. After the command control center operator has activated the mission, the autonomous vehicle starts driving from the postman's home toward the first drop-off point. By arriving at the first drop-off point, the autonomous vehicle completes the third mission. Then the postman takes the first set of delivery packages for the first delivery route. The fourth mission for the autonomous vehicle is to drive to the meetup point at the end of the first delivery route to hand over to the postman the packages for the second delivery route. After the command control center operator has activated the mission, the autonomous vehicle starts driving from the first drop-off point to the first meetup point. Due to the pedestrian zone, the autonomous vehicle and the postman have to take different routes to the meetup point. But because of the road narrowing, the autonomous vehicle triggers an emergency stop. The next step is for the command control center operator to remotely analyze and solve the problem so that autonomous vehicle can continue the mission. First, the command control center operator gets informed about the emergency stop of the autonomous vehicle. After remotely analyzing the situation, the command control center operator reconfigures the autonomous vehicle to limited autonomous driving, which limits the driving speed but uses a smaller safety distance. During limited autonomous driving, the operator remotely observes the autonomous action of the vehicle. In case a safety risk emerges, the operator may remotely trigger an emergency stop. Under the observation of the remote operator, the autonomous vehicle can now continue its mission to drive to the meetup point at the end of the first delivery route. Finally, the autonomous vehicle arrives at the meetup point, completing the mission. When the postman arrives, he takes a second set of packages for the second delivery route.